Okay, welcome to Unit 15, Lesson 4, which is scatter plots and regression. So for this section, if you know how to do this information on your graphing calculator, you're welcome to, but there's actually a website that we are going to utilize, so every student has access to it. So a scatter plot is basically just a graph with data points. I mean, it really, when it says scatter plot, it really just looks like a bunch of dots all scattered around. Okay, so we are going to be finding what's called the line of best fit, which is also called the regression line. They're interchangeable. So basically, it is a line through your data that describes how a y value changes as the input, which is x, changes. So just like any line. But basically we use this line, it's specifically calculated. It's used to predict values that are not given in your data, and we can predict them pretty accurately as to what they're going to project to be. So a lot of businesses use this information. Okay, we're going to wait for this. I want to explain one more thing. So go to the second page of your notes. And it's called the correlation coefficient, which is a lowercase r, okay? So correlation, it describes the relationship between the two data values and the regression line that you're going to calculate, okay? So you won't be doing this by hand, but if you look at all of these examples, you're going to notice some are positive and some are negative. So it describes the closeness to the linear regression line, and it also tells you the direction of the data and the line as well, okay? So these are some examples. So if we had a correlation coefficient of negative 0.90, what you'll notice is the closer you are to 1, the stronger your correlation is, and so your data is going to be closely gathered around that line. Okay, if we have an R value, so this is pretty strong. If you look at the chart down below, we can classify this. So if we have 0.9, that is classified as a very strong negative correlation. Okay, so the closer to 1, there won't be anything over 1. So that's a pretty good predictor of your data. If we have an R value of negative 0.5, so that follows into a moderate negative correlation. It's not as strong, so we can still predict, but if you look at your data value, it's spread more apart and away from that linear regression line, okay? If we have an R value of 0, that is a very weak correlation. And so you'll notice there's not even a line drawn in the middle because our data is all over the place. An R value of positive, so this is a positive 0.5, kind of looks like the negative, and so this is a positive moderate correlation. You're going to be asked to classify R values. And so you see as our data, like as one value goes up, our other value goes up. And our data is spread kind of away from the line, but the line still goes through the middle of that data. And an R value of 0.9 is also a positive. So our slope is positive going up. Positive, very strong correlation. So 0.9 is kind of right on the border. So we won't test you with that. I'll have like 0.91. All right. So the closer to 0, the weaker correlation that you have. All right. So let's go back to our example. So we are going to go to this website, and I will bring it up on my screen. Okay. And we are going to add those data values in. So I'm just going to go in order from the table. We've got 10. And I'm right here on the table. That's where I'm adding them from. So I've got 10, 3.24. And just hit enter, and it will go to the next one. So we're going to put 7, 2.26. If I hit update plot, oops, I don't want the best fit yet. It shows those 2 points. And then you can just go back in your table, and we'll enter in the rest. It does put them in order, so don't worry about that. 9, 2.89. We're at 10, 3.19, 13, 5.10, 5, 1.59, 8, 2.52, and 4, 1.29. So you want to enter in all those data values, and then I'm going to hit update plot. So on my paper, I'm just going to draw it, but you don't have to. So it's just like a couple little dots, and then there's one that's off. Okay, so we are going to find all the information that this website lets us. We want to display the line of best fit. So notice it draws the line in for us, and it does all the calculation. So you are not going to have to do that by hand. So question number 1, our correlation coefficient is positive 0.978. So that's a very strong positive correlation. So very strong positive. You always want to say the type and if it's positive or negative. Okay, so the slope is the slope of the line. So it's the coefficient of x. So we've got positive 0.396. So just like slope, it's kind of like we put it over 1. So that means if we're talking about dollars and gallons, it means that for every $1 spent, we bought 0.396 gallons of gas. So you want to use the labels in the problem. Okay, the y-intercept is the number after x, so this is at negative 0.504 from the screen. What does the y-intercept mean? So that is where we cross the x-axis, which is right down here. So that means at 0, so when we spent $0, that means that we bought negative 0.504 gallons of gas. And there's reasons for this, and we're not going to think too much about that in this class, but that's more for interpretation in a business class. Okay, the equation, we're going to write that whole entire equation. So 0.396x minus 0.504. All right, so if we spent, let's get back to my paper bigger. So if we spent $20, how much gasoline would we purchase? So we want to predict using our line of best fit. So that means that x equals 20, so we're going to plug it in to our equation. All right, and then we're going to type that into a calculator, and we get 7.416. So what we were finding is gallons of gas. So gallons of gas. And I don't round it at all, so I just left that. Okay. And so if we plotted that on our graph, because our correlation is really strong, it's going to be pretty accurate. Not exact, but a pretty good indication. All right, so to reset your data for your homework, you'll just hit the reset button right down here, and then it starts over, okay?